Imagine, if you will, that you are stepping into a small, unassuming machine. The door closes with a quiet, reassuring click. The ambient lights of the room slowly fade to a gentle darkness. Before you, a single brightly illuminated button beckons. You press it. A digital clock on the console begins to blink, its numbers spinning backward at an incredible speed. This machine is our vessel, a time machine of the mind. We are not traveling to see ancient empires. We are not traveling to see prehistoric creatures. Instead, our destination is the very birth of an idea, the first flickering thoughts that allowed humans to communicate with machines. We will travel to meet the pioneers, the brilliant minds who first conceived of giving instructions to these complex contraptions of wires and circuits. Our expedition has a clear and simple purpose. Our journey begins in an era of giants. We find ourselves in the 1940s. Computers were colossal machines that filled entire rooms. These behemoths were marvels of engineering. ENIAC, Mark the Frun, covered in thousands of vacuum tubes, countless relays, and a labyrinth of wires. They had no screens as we know them, nor keyboards for typing commands. Operators used a painstaking process, flipping switches, plugging and unplugging cables. The very first language was the machine itself, machine code, a language of pure numbers. Ones and zeros controlled electricity and circuits. Writing machine code required extreme precision and patience. Programmers had to know the computer's intricate architecture, each sequence mapped to basic operations, adding numbers, moving data between memory locations, or halting the program. They wrote long lines of numbers, checked them carefully, then entered them by punch card or paper tape. It was slow, arduous, and error-prone. A single misplaced 1 or 0 could make the whole program fail, yet it let humans instruct an electronic brain to perform complex calculations. In the 1950s, people looked for a better way. That led to assembly language. The next stop brings us to the late 1950s, a period of explosive innovation. Complex scientific problems pushed assembly to its limits. At IBM, John Backus led a team to create a new language. They wanted scientists to express problems more naturally. In 1957, they unveiled Fortran, formula translation. Programmers could write math that looked like algebra on paper. A compiler translated high-level lines into many lines of machine code. This freed programmers from hardware details to focus on the problem. It reduced coding time and cut down errors, opening computing to non-specialists. In 1958, MIT professor John McCarthy introduced Lisp, list processing, built for artificial intelligence, symbols, logic, ideas. Its core was the list.